Dear friends, judging by the comments in the previous video, not everyone fully understands how the air conditioner works. How does it transfer heat? Let's try to figure it out. To begin with, let's consider what elements the air conditioner of the outdoor unit and the indoor unit consists of. The outdoor unit has a compressor. In principle, you can see its operation of the device in this video. One heat exchanger, called a condenser. And a second heat exchanger in the indoor unit. In air conditioners there are also such devices as a four-way valve, a filter dryer, a check valve, various sensors. Well, here we will not consider this, we will consider a simple example. We have a closed system through which Latigen recirculates. Latigen is in our system in the form of a vapor-liquid mixture. That is, there is both a liquid refrigerant and a gaseous one. In this state, it obeys a clear ratio of the temperature of the liquid refrigerant and the pressure of saturated vapors. This ratio can be seen on the refrigerator ruler on the onometric collector. Well, I'll tell you about it in another video. Let's just assume that this ratio is very clear. That is, if we know the pressure in the system, we can find out the temperature of the refrigerant or vice versa. If we connect the system in this way, then we will get a closed loop. Compressor through the condenser, through the evaporator back. But in this form it will not work, it will just drive around the circle of the Latigen and there will be no heat transfer. To do this, we need another throttle. The throttle is a very thin tube with a small flow section, which supports different pressures and the compressor being created. To make it clearer, we will depict the high pressure area in red, the low pressure area in blue. This is where the throttle is located. It is located in the outdoor unit, meaning it separates the areas. There's high pressure and there's low pressure. When the air conditioner turns on, the compressor begins to drive the Latigen along the contour, thereby it accumulates here, a higher pressure is created, and here a lower one. At the outlet of the compressor, the refrigerant is in a gaseous state and with a high temperature within 60 degrees. The pressure in this part of the circuit is high and has the same value everywhere, in this part of the circuit low also has the same value. The pressure in this part will take 14 atmospheres, the pressure in this part of the circuit is about 4 atmospheres. The compressor pumps the refrigerant in a gaseous state with a temperature of about 60 degrees. Then it moves through the condenser, blown, the outside air temperature is 25 degrees. As it passes through the condenser, the superheated gaseous refrigerant begins to cool down. At a pressure of 14 atmospheres, the refrigerant is cooled at 38 degrees Celsius. Moving along the condenser, the refrigerant cools down to 38 degrees, somewhere at this point, the refrigerant begins to condense and this procedure takes place at a constant temperature of 38 degrees, until the entire Latigen condenses. It will happen somewhere at this point. That is, we have this area with the same temperature of 38 degrees. The temperature, as we remember, is about 25 degrees outside. Further, when the entire Latigen has condensed at this point, it cools down a little more, this value is called supercooling. At the outlet of the air conditioner, we have a liquid refrigerant with a temperature of about 32 degrees Celsius and a pressure of 14 atmospheres. After passing the throttle, we have a refrigerant with a pressure of 4 atmospheres. The pressure drops, then the temperature drops. At this pressure, the temperature is about 3 degrees Celsius. After passing the throttle, part of the refrigerant evaporates and we again have a parafluidic mixture, which cannot change its temperature until it completely evaporates or condenses. The air is blown warmer, let's say the same 25 degrees in our room. The refrigerant, passing through the evaporator, begins to evaporate, thereby absorbing the heat of the internal air. Here he gives it away, here he absorbs it. And somewhere at this point it will completely evaporate. The temperature will rise a little more by the amount of overheating. These two values are overheating, hypothermia. These are quite important values to ensure the normal operation of the refrigeration circuit. To summarize, an air conditioner is a machine that pumps thermal energy along a circuit absorbed by Freon. In this mode of operation in the cold, heat is given to the environment here, absorbed from the environment here. The movement of thermal energy occurs in this way, in this direction. That is, from an indoor room on the street. When working on heat, the movement of thermal energy occurs in the opposite direction. But I'll tell you about it in another video. If you have any other questions, you can write them in the comments. If you liked the video, we like it. If you didn't like it, dislike it. I will be grateful for any activity. Thanks to everyone, bye to everyone.